mining activity. There is a seepage of water, groundwater into the mine excavated area. Together we have the rainwater accumulation as well as the groundwater seepage accumulation. So when we compare this thing with the mine cycle, at the bottom you can see this precipitation as well. Precipitation is the green water in terms of footprint, and the groundwater seepage, that is blue water. And from the precipitation, we could expect some sort of infiltration of the green water, and from which, when there is a accumulation of the water is being impounded in the mine sumps, from which there is infiltration in terms of blue water, there is evaporation in terms of blue water. But when the water is traversing through the high wall phases, it gets in contact with the ore body, that leads to the gray water. So these are the different water that can be taken into consideration while doing the water footprint calculation for the mining processes. So the way forward, this is the recent communication received from the Ministry of Coal regarding mine water mapping, as TBN sir addressed in his concluding remarks. Also, mine water or mine pool water has to be channelized in a proper way to address the water paucity in the India. And so to address that one, our GM R.K. Singh sir, under his directives, we have worked out on water mapping for the different mines across Coal India Limited. So before that, we have taken the principle of doubling principles for doing this water mapping. And doubling principles, see, supply side, we do not have any control basically when we are doing this water footprint assessment for the mining sector. So whereas in the demand side, that is from the industry sector point of view, we can address how this water footprint can be offsetted. So these are the statistical figures coming across the wall. I mean, when you see this figure, you can see the dewatering across the wall, and the highest dewatering is happening from the Bolsward mine, that is in the USA, where the abstraction rate is 390 cubic meter per day, and after that. Konkola, that is a limestone mine, which is having around 3.4 cubic meter per day. When it comes to the other mines which are having the less dewatering rates, this is the global scenario. Let us compare same thing with the Indian scenario. Basically, I am taking the examples of fossil fuels only. So fossil fuels are distributed in various valleys, that is Damodar, Mahanadi, Godavari Valley. These are the major valleys in India that is contributing to the solid fossil fuels. And let us compare same thing with the let us compare same thing with the groundwater resource assessment. Left side you can see the India map with the categorization of the assessment units based on the recent GEC 2015 based estimates. So here, as I said here, you see these central Indian coal fields. When we superimpose them over here, you can see majority of the coal mines are falling in semi-critical to safe to semi-critical, I would say, barring a few blocks which are of critical and overexploited. So 98% of the mines are falling in the safe to semi-critical category. So that is what the emphasis we can draw out of this one. We will discuss in the later session. And when we take these mines statistics, so this is the scenario. Again, from the mines,